Hi class, this is the last method in this lesson, and it's called the reverse method. Again, this is a strategy that I think will be more useful for young students as they're starting to approach solving equations, rather than, hey, you have to distribute first. Why do you have to distribute first? Well, I don't know. You just distribute first, and then you need to add 3. Why do you need to add 3? Okay, this really tries to connect with student thinking. And to build on this, you help the student see, well, we have a number here, x. We don't know what that number is. But if I had that number x, what would you do on this side of the equation to figure out what that side of the equation is? Well, you would need to use order of operations. First, you would do your parentheses, then you would do your exponents, then you would multiply and divide and make sure to do that from left to right. So you don't do multiplication first, then division. It's whatever happens to come first, left to right. Same with addition and subtraction. You don't do addition first unless addition's on the left. If you've got multiple ones, you just go left to right. All right, so if I look here, if I have x, what do you do to x first? Order of operations? Well, we do our parentheses first. All right, so we look in here. Then what do we do next? Inside we have a multiplication, we have a subtraction. So the first thing we do to x, if we know what it is we multiply it times 2. Once we get that answer, we then subtract 1. And then we have that answer, we then need to take that times 3. And that should give us 33. But if you think of this as a series of steps, I started with a number, x, times 2 minus 1 times 3 gives me 33. How can I go backwards? How can I reverse that process to get back to x? Well, we start with 33. The first thing we need to do, instead of multiplying by 3, we need to divide by 3. And that's going to give us 11. Then, instead of subtracting 1, I need to do the opposite. I need to add 1 to get 12. So if you think about this, I had 11, then I times it by 3 to get 33. Going backwards, I divide by 3 to get 11. So what did I have before I subtracted 1? I must have had 12, because 12 minus 1 is 11. 11 times 3 is 33. And then I go back. Instead of timesing by 2, I need to divide by 2. So 12 divided by 2 gives me 6. So here, x must have been 6. 6 times 2 is 12. 12 minus 1 is 11. 11 times 3 is 33. And that gives me what x was before I did this series of steps. And so now I've reversed those steps to get back to what 6 is. Now, I know you're comfortable with distributive property. I know you could solve this without using the reverse method. I know the reverse method is probably strange to you. But do you remember back to when you first started learning to solve equations? I'm guessing it seems strange to you then as well. Here, it's really building on the relational thinking, x times 2, so some number times 2 minus 1 times 3 equals 33. Here's the other great thing. Let me shrink this down. If I solve this, and again, I would have to skip the distributive property, but 2 times something, this first step, 3 times something, this first step, I would divide both sides by 3 and get 2x minus 1 equals 11. Then I would add 11 to both sides. Sorry, not 11, 1. See that 2x minus 1, I just copied it wrong. So then I add 1 to both sides. That gives me 2x equals 12. And last, I divide both sides by 2. X equals 6. Do you see how this process matches the student's intuition here? And that's what we want to do. We want to build on students' prior knowledge and prior understanding. And so here, I first divided by 3. I then added 1. And then I divided by 2. So the standard method ends up matching what they did here. Now I would encourage you to go into Class Activity 9Q and solve those without using the standard method. Or if you want to do the standard method first, that's fine, and then try to do reverse or cover up. And I'll show how to do those in a